My name is Jan Braband. I'm one of the founders of ActiNovo. I actually am a computer scientist. I studied a few semesters of medicine, but my degree is in computer science, and I developed the technology, the actual technology that we use to produce our liposomal formulations together with a pharmacist and a chemist about 7 years ago. And as I said, we have this own technology with our own machines here in Hamburg, Germany, where we produce the liposomal formulations. I'm going to tell you a bit about liposomes and liposomal formulations and why their impact on the dietary supplement industry is tremendous. I think it's a really great technology, and you will hopefully see why in the next 30 minutes. Thank you very much for attending. So, why are liposomes the future of supplements? I'm going to go through a couple of things. We are talking about what are liposomes actually made of, what are liposomes, how do they contribute to bioavailability, what is a bioavailability, although you might know that. Also some technical things about how can you prove the existence of liposomes, and so on. Okay, let's jump right into it. If you have questions, please use, as Diana said, the Q&A section and write them in. I cannot promise that I will answer them right through the presentation, but afterwards, as Diana also said, there is enough time to answer your questions, no problems. Okay, liposomal formulations, liposomes. First of all, what are liposomes? Liposomes are made of phospholipids, another term, unfortunately, you need to learn if you might not know it already. And phospholipids are very interesting. It's a very interesting molecule. It consists of a hydrophilic and a hydrophobic part, meaning one part loves water, one part does not love water. What does that mean? If you put these phospholipids into water, they form double layers, meaning that the not water-loving parts come together, as we can see here in this graphic, and the water-loving part faces towards the water. Now, this does not automatically make a liposome at all. We will come to that back later. But water, and that is a very important thing, and that water is a absolute vital part of a liposome. Why am I saying that? Because recently there have been some developments that there are liposomes without water, sometimes even without any fluid. And honestly, these can't be liposomes by definition. Even if you can produce them and then would remove the water, it would not be possible to keep these liposomes stable. Think a bit of a bubble, in a soap bubble, and if you would put the air out of it inside and outside, it would immediately become unstable. Although a sphere itself is a very stable geometric figure, it needs the water inside and outside to be stable. So water is a defining parameter of a liposome. No liposomes without water. What are phospholipids in detail? We see one here. This is a phospholipid. Phospholipids, it's important to understand, is a group of molecules. So there's not the one single phospholipid. There are numerous quite famous ones that you might know, like 𝗵𝘃𝗴𝗁. It's a pretty famous and known one, and they all consist of a head the hydrophilic, the water-loving head, that contains a phosphate molecule with a phosphorus atom, and contains of glycerol chains. And then come the multiple fatty acid extensions, which make the hydrophobic tails, so the rather fat-loving, water-not-loving part. And these can be consist of a multitude of different fatty acids, but it's not so important what exact phospholipid we have. There are numerous phospholipids that are very, very capable of building out this bilayer that we are looking for, and so it's not necessary to have one specific phospholipid. If we look at the membrane of a cell, of a human cell, then we can see a different kind of phospholipids that combine together in an aqueous, in a water environment, and then build these double membrane layers. So what is the difference between cell membrane and a liposome? Actually, not that much, and that's the great thing. I have to admit that a cell membrane has some other additional features. For example, they usually have transport channels and some other things that makes it easier. It makes it easier for the cell to communicate with the outside, but the actual cell membrane can be considered identical to what we have in a liposome. Only that a liposome usually is smaller. A cell is, as you might know, rather big, but concerning the sizes, we get more information pretty soon. So, why is it good that liposomes consist of phospholipids? Because our body loves phospholipids. As I have said, all our cell membranes, so everything that defines our cell as the border of our cell, consists of phospholipids, and therefore phospholipids are needed, required in abundance by our body to build up cells. So phospholipids are a vital molecule. We need them, molecules, and we need them. And so our intestines are, of course, very interested in resorbing, in receiving phospholipids. And that's the actual trick. We use the desire to get phospholipids by our digestive system. We use that trick to kind of smuggle in other compounds that usually would be selected out, or at least would be selected out by a big factor. So you could think of a liposome as a Trojan horse. There's this little, maybe you know this story. Of course, you know the story of the Trojan horse. You know the Trojans in the Greek wars. The Trojans tried to the Greeks tried to get into Troy, and so they put a few soldiers in this wooden horse, and the poor Trojans did not realize that what was inside the horse, so they moved the horse in behind the city walls, and then the soldiers came out, and that was that. So, and that's exactly what we do with the liposome. Our digestive system sees the liposome, sees the phospholipids, wants the phospholipids desperately, and resorbs them. And inside, hidden, we smuggle, we transport the active compound that we want to get into the bloodstream. And that makes it really, this is the biggest feature, this is the game changer actually, because and that comes then we come to the next point, the bioavailability. Bioavailability, you know it, of course, it's the percentage of a substance that actually makes it into the bloodstream and is therefore available for the metabolism to be further processed. Of course, it's not enough just to put a substance into your mouth, because what is it good for if your digestive system does not resorb it, does not process it, and just delivers it straight into the sewage system or into the toilet, how I could also say. So bioavailability is a very important factor. It's sometimes a bit more complex, the topic bioavailability, than what you might think. I know we ourselves often state a simple factor by which our products are more bioavailable. And to be honest, this is scientifically not 100% correct, because there's not a single factor. Because it's not just the ingredient itself, it's not just the substance itself that must be accompanied with a bioavailability factor. It's also the amount that you want to transport into your digestive system and into your bloodstream. Why is that? Because if you have very small amounts of in a substance, it's usually not such a big problem to get it into your bloodstream the old, usual, traditional way. Think of an apple. If you eat an apple, you will most likely be able to resorb most of its vitamin C content of this apple. So actually, you could say the vitamin C has a bioavailability of 100%. No need to ever think about like an infusion or think about a liposomal formulation, because if you have a bioavailability of 100%, why do you would you? It's not possible to make this bigger. 100% is the biggest. So, but with the apple, you only get a few milligrams of vitamin C into your bloodstream. It's only a few milligrams that are contained there. And even if you eat 1,000 apples, which obviously is not really practical, and possibly not even not even possible, because your digestive system would rebel if you eat 1,000 apples. So there's a natural kind of border. It's not one constant factor. It's a curve, and it's this curve goes towards over a knee, towards a certain maximum, and over this point, it's just not possible to resorb any more of a certain ingredient. And this is something we can clearly overcome with a liposomal formulation, because the selective forces are not in use anymore. So we can have we use the liposomal formulation to overcome this. Yeah, so what exactly does that mean concerning a factor? Let's take another example. A few milligrams of an apple of vitamin C. How about if you want to work with 1,000 milligrams? 1,000 milligrams, for example, as I said, you couldn't eat so much apples to even get close to this number. And if you just take a tablet with 1,000 milligrams, it's also known and proven that your digestive system will not be able and is not willing, you could say, it's even trained to not absorb that such high amount of a certain compound. It's just not trained by evolution to do that, because it never happened in the past in nature that such a high amount could be administered orally. So there is just no way around in like an intravenous injection or a liposomal formulation to get that amount into the bloodstream. So I would like to come back about the term liposome and phospholipid complex. As I said, liposomes are made of phospholipids, and therefore liposomes are also considered a phospholipid complex. It's a synonymous term in that direction. So liposomes are phospholipid complexes. But phospholipid complexes are a term that contain all kind of phospholipid spheres and geometric structures. My cells, for example, which are one layer structures of phospholipids. Why is that important? Because liposomes are considered to be the kind of, well, best phospholipid complex you can choose, especially to bypass the selective forces of the small intestines. Meaning that if we talk about phospholipid complex, we also sometimes talk about phospholipid complexes that they are also, of course, and since they contain liposomes, they are very, any liposome that can mask a substance, any phospholipid complex that can mask an active substance will do the job, but a liposome with its bilayer and cell membrane compatible structure is always has always an advantage. Concerning sizes, how big are liposomes? Usually, we consider liposomes spheric structures with a size of 50 to 400 nanometers. This is by far not an exact definition. They can be smaller, they can be bigger. As we can see here in this graph, cells, and I said basically cells are defined by the outer membrane, and the outer membrane in turn is close to identical to a liposome, and they are much bigger. They are much bigger than a liposome. So they can be bigger, but this is not something we want to go for. We think the best size, or really size that could be recommended, is in the range from 100 to about 250 nanometers. Why not smaller? That has some legal implications as well. There are new, or rather new, laws and initiatives by the European Union now that consider structures that are man-made, and liposomes are man-made, even if they are identical to natural structures. They consider them to be a nanostructure and nanomaterial, and being a nanomaterial, they are often considered in a couple of countries now considered to be novel food. And if they're considered novel food, you need a certain application procedure to bring them to the market. And this is something we dispute, honestly, because we think it's in the end a natural transport mechanism, and the actual the active ingredient is usually a known ingredient, like a vitamin, and there is nothing novel food about this. But to make the argumentation a bit easier for us and for the client, it's we adjusted our production process to not produce liposomes that are smaller than 100 nanometers, because this nanomaterial regulation specifically sets a barrier of 100 nanometer. So if it's above 100 nanometer, it's not considered nanomaterial, therefore not considered novel food. Therefore, chances are much better that these products remain just a normal dietary supplement, a food supplement. So how do we actually see liposomes if they are so small? It's actually pretty difficult. because due to the size, you can't use a microscope. A light microscope, as you know it, can maybe enlarge to 2000, be 2500 times, but that's the absolute maximum. Beyond this is a physical barrier due to the wavelength of the light. And it's just not possible to enlarge it anymore. And a 100 nanometer liposome would, with 2000 times enlargement, have the size of 200 micrometers. That's 0.2 millimeters. And you can't see anything that is 0.2 millimeters in size. So they're too small for a light microscope. Of course, there are things like scanning electron microscopes, and they can enlarge much higher, but you need to prepare the sample, and you need to prepare it extremely. And you usually, in terms of liposomes, you damage some part of the product. So sometimes it's possible to actually see a liposome, and you can see and give some quality, can see some quality aspects of a single liposome, but you can never estimate the quantity with this method. So this is also not really used in reality. What is used instead is a particle size analyzer. It uses laser diffraction, so a laser beam that is put on a sample and then scattered, and then there are different electrodes, photoelectrodes, and the sample is then analyzed. And there's only one device in the world actually that is capable of going down to 40 nanometers of size with an additional additional system, but I won't go into this. And this device is made by Beckman Coulter. It's an American company. They are. This is basically the state-of-the-art method to analyze this kind of formulations down to 40 nanometers. And we have such a machine here. So we use it in our R&D department to frequently look at the formulations that we produce in our own factory. And what you receive is such a curve here, which tells you the particles in micrometers. So 0.1 would be 100 nanometers. I said we don't do right now particles that are smaller than 100 nanometers. This graph here is a bit in contrast of what I just said. That's because it's an older one. This is from 2017, I think. And as I said, we with our production process, it's very heavily relies very heavily on IT algorithms, and we can, I don't want to say freely, but can very easily adjust the liposome size with our method. And if we would have just random particles here, so not liposomes, but particles that are not sphere-sized, you would receive a curve that has not this nice curved shape, but it's more or less like a random peaks and then drops off. So this is actually the state-of-the-art method to determine quality and quantity of liposomal formulations. What can be encapsulated? Well, actually almost everything that you want to. Meaning one limitation is of course the water. As I said, liposomes require water always, which is also a disadvantage, a small disadvantage, because water also is loved by bacteria and fungi. So you actually need to, it's a delicate product. It's not a super robust product. We now have it at around year and a half of shelf life is not a problem, but it's not a product that you put into shelf and open after 5 years and it's still in exactly the same condition. That's not going to happen because of the water. But you can put virtually anything into water, even non-soluble ingredients. Think of plant extracts. Most plant extracts are not water soluble, usually not at all. But we just create a suspension. Think of milk. So we just have the devices to spread the tiny particles in water, and usually if you would wait 24 hours, everything 99% would sink down to the bottom. But then our encapsulation process begins, and we encapsulate the particles in suspension, and therefore we are able to encapsulate virtually everything, anything. Bioavailability, I said a bit about bioavailability, but actually, how can we prove that? I showed you this very nice device, which we are very proud of, with which you can determine the quality and quantity of a liposomal formulation, but that does not prove that the ingredient actually makes it into the bloodstream. Not at all. It's just another completely different field. And that's the reason why we initiated a couple of bioavailability studies. And to clarify that, you need to understand we are not working in pharma, so we can't afford to conduct studies with thousands of attendees. That would cost many millions. But what we do is we have a very clever and very sophisticated partner in India, and they conduct these studies for us. So they select 2 groups of 10 participants each. And each participant, 10 participants receive the ActiNovo formula, and 10 others receive a competitive product. Can be non-liposomal, but and that's the control group. It's blind, so it's a blind study. So the participants do not know what they receive, and the results that we receive, admittedly only from 2 times 10 participants, but it's still significant, and the results are really promising, and we are very proud of them. The dosage applied in the vitamin C study was 1,000 milligrams. I just got the question what the dosage was, and so we have this graph here. You see the ActiNovo liposomal product, and maybe it does not even look so super impressive. It's you could be easy to say, well, it's just 3 times more or so, but this is not how it's done in science, and that's not the relevant thing. There is a factor, or a parameter. It's called the area under curve, AUC, and you could see that if you just look at the area, so the amount that is in the bloodstream over time, and if you look at this area here compared to this area here, you'll see the tremendous difference. So there is a tremendous difference for vitamin C. We did this for a couple of other ingredients as well. I'm sorry, I'm a bit over time. I need to speed up. As you see here, our glutathione study, the study with curcuminoids. Curcuminoids are a group of molecules that make up the most important molecules, the active molecules of the curcumin turmeric plant, and there we have with curcumin. It's beyond dramatic, to be honest, which is not so surprising because it is known that plant extracts have usually a very, very bad water solubility, and combined with that, a very bad natural bioavailability. Okay, so why are liposomes now the future of the dietary supplement industry? Well, first of all, we think that with all the attributes we have, so we have the proven, we have the studies, which, by the way, of course, please talk to Diana or Sarah or any other of your contact. You can ask for these studies in detail. We can send them to you, no problem at all. So what we can offer with the ActiNovo products is to have a liposomal formulation that is, yes, more expensive than the normal application, but it opens up a full universe of new possibilities. Because, as I said, there are a lot of ingredients, a lot of substances that you just can't get into the bloodstream orally, if you want to achieve a certain little bit higher amount. If we're talking about very, very small amounts, usually no problem. If we're talking about medium, higher amounts, it's just not possible. So even if people took a lot of substance in the past, it was basically for the toilet, most of it. So we never knew actually how all these ingredients actually could work if they could be fully transported into the bloodstream, and that's possible now with a liposomal formulation. Admittedly, it was possible as well with an injection, but who wants to apply an injection every day? This is not really practical. Okay, the ActiNovo products are soy-free, gluten-free, lactose-free, vegan. Usually they are. Please see, sometimes they're very, very, very special ingredients that are, for example, not vegan. It's very rare, but usually we try to achieve this and take it very seriously. We take the main ingredient, the phospholipids, come from lecithin from sunflowers. Made from a European, actually German manufacturer. I consider them the best phospholipids you can buy in the world, and I stand by that. We have a GMP ISO 22000. There's 10 missing. I'm sorry for this. It's ISO 22000 certified, meaning we have yearly audits where SGS, that's an auditing company, comes to our production facilities and checks if all the documents are flawless and in order, if the production is clean and fine, all that. So this is all been taken care of, and of course we have a very, very revolutionary. Try not to use this word too often, but I really think it is. We have the sea buckthorn for preserving our formulations, meaning we have a natural way of keeping bacteria and fungi at bay, so that we have, with this water-based formulation, a good shelf life. We are almost done. In sum, why are liposomes the future of food supplements? Well, as I said, through the higher bioavailability, you have better business. And it's the best argument you can have. It's proven by facts, proven by logic and science. Honestly, I talk to a lot of people and a lot of scientists about liposomal formulations. And sometimes it happens that someone tells me, yeah, it's too expensive for me. I can't afford it. I do not want to afford it. I do not believe in supplementing anything. All fine, but never honestly. I have encountered someone, scientifically educated man or woman, who told me, yeah, I understood what liposomes are, I understood how liposomal formulations work, but I think it's just not working. It's not. It doesn't make sense. I never heard that. At all, never. So you can always argue it's too expensive, fine, but you can't argue it's not working. Definitely not. But for me, the last sentence is actually more important. It's not about a simple factor, how more bioavailable a product is, a substance gets. It is about that you now can put substances to work, substances that we already know, but substances that now can finally get to work. Before, it was just not possible. Think about Resveratrol. You might have heard about Resveratrol. It was very, very hyped in the end of the 90s. It's a super, super strong, it's a polyphenol. It's a very strong antioxidant. It was favored as being a life-extending compound. It's made from from grapes, simple grapes, the seed or the grape. And therefore it's existent in red wine, for example. And it was very much hyped because in vitro, in theory, I say, in the lab, it showed extreme promise of being extremely effective when it comes to its antioxidant properties, and also some other properties. And then the studies were conducted, and they were all disappointing. Very disappointing. Nothing really happened. Nothing really you could measure. And then it turned out, well, everything that was administered, usually in the 100 milligram region, only a small fraction in the range of 1 to 2 milligrams actually made it to the bloodstream. So no wonder, no surprise that this could never be a success. And still, we know it is a compound with extreme potential. And now we have the possibility to actually bring it to the bloodstream. So there's a lot of research. There's a whole universe of possibilities now, and a lot of research has to be done. Not just by us. We can't do it alone. It's impossible. But by the research community now to reevaluate these tens of thousands of compounds that can now be easily brought into the bloodstream. Okay, sorry, I I'm 12 minutes late, 10 minutes late. Thank you very, very much for joining. And now we come to the Q&A section. If you have any questions, I'm more than happy to hear them, and hopefully I can answer them. I'm going through something that is in the chat. Give me a few seconds for that, please. Okay, there's the question, with the advantages of the increased bioavailability come disadvantages as well, e.g. interactions with other supplements and or medications. This is especially valid for herbal formulations like curcumin. How do you provide advice in the respect to therapist's client? It's a good question. It's a true question. It's, let me answer this. In the end, what we provide is a product using better technology to offer, great technology, to offer a much higher bioavailability. So you get more into the bloodstream. What happens then when it actually is in the bloodstream is a completely different and extremely complex topic. And honestly, this is beyond our scope. Because we would have to conduct studies. What are curcuminoids? What are glutathione? What is vitamin C, vitamin D actually doing in the body? And where do you want to stop? It's not just the how does it affect a certain organ? How does it affect the whole metabolism? We need to base our recommendations on what is known about these compounds. Therefore we also need to be need to ask for caution and not to recommend customers to take too much, because yes, this could easily mean that they become guinea pigs if they just take amounts beyond the recommended daily dosage. With a lot of normal products, it's not a problem. With liposomal formulations, it can get dangerous. But in the end, it's the same question everywhere. You know, it's like if you take a pharmaceutical product, if you take ibuprofen 400 milligram, you can buy now in a simple drugstore. 600 milligram, you need a prescription. So you take 2 of the easily bought one from the pharmacy, or you take 10 ones, and you are in dire danger. It's really dangerous. So these products, yes, come with some responsibility. That's no doubt. I can only tell you, we will focus on in the future on the bioavailability. Make sure to prove to everyone that the active ingredient makes it into the bloodstream. The step from there, what is it actually doing in the bloodstream, is a different question that is beyond our scope. Okay, I had another question. Are ActiNovo products made in Germany? Yes, they are all, and without any exception, made in Hamburg, Germany, in our factory here in Hamburg. Can it be used for pets like dogs? That's also a good question. I wish I could give a very easy answer, which would be yes, and actually it could be yes. Of course it could be used. There are some legal obstacles. I can only talk for Germany now. The pet market is a veterinary market is regulated by different laws and regulations, which sometimes makes it difficult to apply human products to pets officially. Of course, you can do personally whatever you want, but it could be difficult to advertise it, to tout it. We do not pursue any legal advice in this direction, although again, I think yes, pets can benefit from it. I've talked personally, I know it's now 4 years ago, was more in the beginning of time, to a guy from the Netherlands who used our curcumin, who used ActiNovo curcumin to treat his dog, and he was successful. I don't know if it was the ActiNovo product, maybe it was also another procedure, but someone did this, yes. Okay, I'm quickly going through the other questions. What encapsulation efficiency you aim for your supplements? Also a good question. Encapsulation efficiency we aim at is in the range of 85%. So usually from the tests we made, we sometimes reached 90+%, but I think 85% is a very safe value and serious value. And this, we could actually filter out everything that is non-encapsulated, but it would be it would increase the price tremendously. And we think with this about 85 to 90% encapsulation rate, we are at a very good level. Do your liposome size always depend on the active ingredient, or do you keep a stable size around 100 nanometers? Well, the 100 nanometers is the lower boundary, and the upper boundary is 200 nanometers. And this is kept, so we usually have between 100 and 200 nanometers with a peak at around 150 nanometers. So there's a strong peak at 150, and then it drops down to the left, to the right, towards 100 and 200 nanometers. There are some ingredients that agglomerate a lot, so they build natural, very sticky particles, especially some plant extracts, and then it is sometimes possible that you also have a few large particles, sometimes even in the range of to a few micrometers, but they are absolutely in the absolute minority compared to the 100 to 200 nanometer size particles. What temperature range is suitable for storing liposomal formulations? Also very good question. Suitable, we officially say between 4 and 24 degrees Celsius. Honestly, you do your liposomal formulation a favor if you keep it cold. Cold does mean like refrigerator cold. That's definitely a plus. It just supports the shelf life. It suppresses any microbiological activity. So therefore, I would recommend to store it in a fridge, but it is definitely not necessary. Absolutely not. You can ship it also if you have it for 2-3 days at higher degrees. It does not immediately spoil, but again, as cool as possible is definitely nice to have. Please never freeze it, of course. I think you can imagine it. As soon as you get ice crystals, they will immediately harm the liposomes, and they will basically destroy the phospholipid patterns. So please never freeze it. But anything towards 2-3 degrees is also fine, but never freezing it. Okay, will ActiNovo be present at Vitafoods in Geneva in October? Yes, it will. You might find us at our sister company's name, 𝗵𝗃𝗃𝗁𝗃, but please ask Diana for that. We will be at Geneva in October, October 5th, 6th and 7th. What plant extracts and or polyphenols have you managed to create liposomes for? Well, plenty actually. We used, this is actually an ongoing list. We have our production software where we evaluate a lot of ingredients, and sometimes it's difficult. You would have to differ between just a mere extract, which is usually a range of a lot of different molecules, and also containing a little bit of starch and so on. And then you have these very refined extracts where you have just one molecule. Resveratrol, as I said, as a polyphenol, could be considered a plant extract. It's just a single molecule. Yeah, we have, I'd say, at least 40 to 50 we have experience with already. The ActiNovo brand now has on the market, I'd say, 6, 7, 8 ficetine, curcumin. Astragalus is not available anymore, I think. Yeah, so plenty of it. Please, let's get back to that question via email. Do you have any plans for liposome NAD plus or NMN? So the nicotinamide mononucleotide or the NAD plus. Yeah, that's a good question. We hear that quite often. We did already tests that were successful. It is from the legal side. In Germany, it's a tricky product. Let me keep it at that. I think it's not likely that we're going to have it as an ActiNovo product in the near future. But if you're extremely interested in this product, please get back to Diana, and we can talk about if there are other solutions for these compounds or for all the nicotinamide derivatives. Okay, can phospholipids help in weight reduction, obesity? I don't know. I really don't know. It's not the phospholipids are a very nice and very useful carrier that has like an abundance of other health benefits. If weight reduction is one of them, I just honestly can't say. I'm sorry. Can you tell us about any new products coming this year? Will you ever do collagen again? No, well, I think we will do collagen again, yes, because it was a very desired product. We will have a completely new remodeled research and development department that starts by the end of this month. And goal is to introduce a handful of new products in the next months, but I'm sorry, I can't tell you at this moment what they will be exactly. Collagen, yes. Sure. Yeah. Thank you, Diana, for that. I have another question. I'm hesitant to utter this term, but I will do it. It's called liposomal powder-based. Nutrients are cheaper, but how efficient are they? Yeah, I see that as well. You know, it's difficult for me. I really don't want to talk bad about any competitor or any brand. I consider the term liposomal powder a contradiction in terms. Liposomes require water. There's no way about it. And if you remove the water, the liposomes will be destroyed. We have analyzed at the beginning, when we were also a bit surprised that a couple of markets rushed into the market. We just watched it under the microscope. I told you liposomes, you can't see them under the microscope. We watched that powder under the microscope, and you can see the big crystals of vitamin C product. You could see the crystals that were never dissolved into water. And the product we watched from a company I won't mention here, it was not just not liposomal, it was a scam. It was just, it's criminal, honestly, because it has nothing to do with liposomes. There, someone just added vitamin C powder and lecithin powder and mixed it together and sold it as a liposomal product. So they did not even took the effort to make a liposomal formulation and then remove the water, then you couldn't see the big crystals. So this is really extremely unfortunate. I think it harms the reputation of liposomes and liposomal formulations a lot, that people are out there and touting these products that are just do not work, and not by definition they can't be working. And if you look at them, you can do it yourself. Just buy this powder, and if you have a microscope at hand somewhere, and then have a look at it, and you will see the rough ingredients. It's very unfortunate, and it's too good of a product, the liposomal formulation, to ruin the reputation by such a cheap scam. Sorry, it is a scam. Do you control residual solvents if you're using them in your formulations? Yes, we do. What we do is the following, which comes actually with the ISO 22000 certification. So when we decide to work with a new supplier of an ingredient, we usually have the first batch of the ingredient analyzed for any residual material, solvents, but also heavy metals, basically everything that is important. once we see that we can trust the company and we can trust the documents the company sends, then we dial the control down a bit, because it's just not economically feasible to have a full-scale analysis which costs a couple of €1,000 for every single batch of ingredient. It's not possible. So what we then do is that we check the microbiological quality of the ingredient, and we do frequent checks that we analyze ingredients to see if the active ingredient is still the amount that is required to have it in production. Honestly, I think there's not much more you can do. I'm pretty happy with our quality management at ActiNovo, and it's always possible that a problem occurs, but the net is really tight. Okay, I had some more question. The gastrointestinal system has harsh conditions like strong acidity and enzymatic activity. Are the liposomes stable enough to such harsh conditions? Yes, that's the good thing. They are. It's especially over the time. There are actually a lot of studies out there independent from our product that have nothing to do with our product concerning how liposomes or phospholipid structures can bypass the stomach area and the enzymatic influence that starts in the mouth and the oral area and then continues in the stomach, and they are very much suitable to do so. Can we discuss the global success stories of ActiNovo Plantacorp customers? I don't really understand this question. Maybe you can specify more in detail what you're thinking of. And I go through the other questions now. I think I got it more or less. Yeah, well, if you have more, please do not hesitate to write us an email. Write an email to Diana. I'm also happy to assist. And I think we should conclude it now. It's exactly 1 hour, given the fact that we started 5 minutes later. Okay, I have one more question. I'm quickly reading it. Recent studies, it is shown that coating liposomes with hyaluronic acid makes them more target-oriented, especially to cancer cells. Have you considered this, or do you think it is possible to do it? That's a general... to say it in general, there are numerous additional technologies to kind of coat liposomes to make them more directed into targeted drug delivery. There are a lot of PEG coated, hyaluronic acid is also a good idea. So there are different ones. This is actually goes more into pharma. We are doing some research on this as well, but at the moment I have to tell you it would increase the price so tremendously that and since we are focusing on the bioavailability issue, so meaning how to get the ingredients into the bloodstream, meaning being a taxi into the bloodstream, we do not at this point focus on targeted drug delivery, so bringing a substance to a specific area in the body through the blood stream. This would be on top, and as I said, we're doing some research on that as well, but I don't expect it to become a product soon, just because of the fact that it would increase the price, I would say, by the factor of 3. And I think we are then in a price range where the market is just too small. So yeah. Okay, so thank you very much again, and keep posting questions via email, And I hope you have a great day. I hope you will be stay healthy or become healthy, and maybe ActiNovo can help you with this. I can tell you, I take ActiNovo. If you're interested in that, I take every day 10 milliliters of Vibrance and 10 milliliters of Immune and 10 milliliters of glutathione. But honestly, I take for the glutathione, I take the plus variant, because otherwise the taste is really harsh to bear. Although I can also tell you, a lot of people say, I will go with a pure version. I do not want to be bothered with any sweetener or flavor, even if it's a natural sweetener and flavor. So this is also quite an interesting story maybe. So have a good day, be healthy. Thank you very much for watching and listening, and goodbye.